These, my dear classmates, are my pet medicinal leeches. They are blood-sucking parasites, but unlike other macroscopic blood parasites, they have been specially raised to not convey pathogens to their host. So today I will be informing y'all of the relationship between malaria, a blood-borne disease caused by the parasite Plasmodium, and sickle cell anemia, a genetic blood disorder. First, I'll elaborate on what malaria is, then what sickle cell anemia is, and finally I'll tell you how they relate to one another. So let's talk about malaria. Malaria is, as I stated before, a blood-borne disease caused by the parasite Plasmodium. According to the CDC, Plasmodium is usually transmitted to humans via the Anopheles mosquito, and so when someone's bitten by the Anopheles mosquito, Plasmodium invades the bloodstream, essentially hijacks a red blood cell and uses it to reproduce, which then causes the symptoms of malaria. This is important. Remember that about the red blood cell. The symptoms of malaria include flu-like symptoms such as fever, chills, and weakness, muscle aches, and so on. There are also other symptoms associated with anemia due to the loss of blood cells, such as jaundice, renal failure, seizures, confusion, coma, and death, the latter of which are the more severe symptoms. Malaria is most common in poor rural areas and, of course, areas where mosquitoes are widespread. In addition to being spread by these mosquitoes, malaria can also be spread by other forms of blood contact, such as used needles. So in summary, infected blood is transferred from one individual to another, infecting the latter with Plasmodium, which then hijacks the red blood cells to reproduce, causing malaria. Now on to sickle cell anemia, which from now on I will be referring to as SCA. Once again, sickle cell anemia, or SCA, is a genetic blood disorder, and according to the Mayo Clinic, SCA is characterized by the abnormal crescent shape of red blood cells. This shape is abnormal for many reasons. First off, sickle cells die much more quickly than your normally shaped red blood cell, and they are not able to adequately transport substances. Additionally, the sickle shape is incredibly rigid, which leads to cells getting caught in capillaries, which then leads to blood vessel blockages, pain, swelling in the extremities, infection, vision, and developmental issues, as well as the other issues associated with anemia. So in order to have sickle cell anemia, someone must inherit 2 copies of the gene for it, one from each parent. If someone doesn't inherit any copies of the gene, they will not have it or carry it genetically, even if their siblings have it. So if they inherit 1 copy of the gene, they are heterozygous. That is, they will carry the gene and be able to pass the disorder on to their children, but they will not present with sickle cell anemia. It is this latter turn of events where malaria comes into play. So when someone is heterozygous for SCA, that is, they only have 1 copy of the gene, and do not present with the disorder, as I said before. In a paper by Lucio Lozado, this person expands on the interaction between malaria and SCA. If a heterozygous person is infected with Plasmodium, their hijacked red blood cell will be triggered into sickling. That is, it goes from the normal biconcave red blood cell shape to the abnormal sickle cell shape that is characteristic of sickle cell anemia. Because the red blood cell changes shape, it is usually cleared away by the person's immune system before Plasmodium has a chance to replicate inside it. So Plasmodium is prevented from propagating inside the bloodstream. This phenomenon is usually referred to as the heterozygote advantage, because being heterozygous makes someone more resistant to being infected with malaria. To paraphrase an article from Nature Communication, it is theorized that sickle cell anemia has essentially escaped natural selection, because it is more advantageous to keep the disorder in the gene pool, that is, to have people be heterozygous for sickle cell anemia, than it is harmful to have people that present with the disorder. So in a population where malaria is endemic, that is, it is a recurring kind of constant presence, it's better for that population to have some people who are heterozygous for sickle cell anemia than it is harmful for there to be people with full-blown sickle cell anemia. It should be noted that people who are heterozygous for sickle cell anemia are not immune to malaria. They can still contract it and experience severe symptoms, but they are more resistant to being infected. Additionally, according to that same article by Nature Communications, the heterozygote advantage is really only an advantage in populations that have persistent risk of contracting malaria, like I said earlier. And people who have full-blown sickle cell anemia, that is, they have 2 copies of the gene, they have irregularly shaped sickle cell red blood cells, they are more susceptible to experiencing the severe symptoms associated with malaria. Malaria is much more dangerous for these people. To summarize fully, malaria is a parasitic blood disease. Sickle cell anemia is a genetic blood disease, and being heterozygous for sickle cell anemia leads to resistance to malaria, and malaria is theorized to have led to the continued existence of sickle cell anemia. So that was my speech. Now you know a little bit more about blood pathology, and that some things can be widely considered harmful but have surprising ameliorative effects, like sickle cell anemia and medicinal leeches. Thank you.